Okay, so here's the first optimization problem, and this one isn't too difficult. The first thing we want to do is going to be to, well, of course, you got to read the problem, right? You got to read the problem. The problem says that a rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 1 minus x squared. Wow. Okay, what are the dimensions of such a rectangle with the greatest possible area? Okay, so let me circle some stuff here. Let's circle the parabola, and we're not given that much information except that we have a parabola y equals 1 minus x squared. So let's draw a picture of this parabola. 1 minus x squared looks something like this. Okay, and then there's a rectangle inside of here, and let's just assume, for the sake of simplicity, that this rectangle is symmetric. Okay, so here there's a coordinate point. There's a coordinate point. This has an x value and it has a y value, and so this right here, this is going to be x, and this is going to be y. Okay, so after you draw a picture, remember what you do is you write down the formula that you're trying to maximize or minimize. In this case, that formula is the area of the rectangle here. Well, the formula for the rectangle is base times the height. But now we want to put it in terms of this guy, so we know that the base, so it's not x, but the base is actually 2x, twice this much, times the height, which is y. Okay, so then you get the derivative of the function that you're trying to maximize or minimize. In this case, we're trying to maximize it, but we can't get the derivative here because we have two different variables. So we need to write this as a function of, let's write this down, we need to have only one variable. Whoopsie. I'm writing pretty curvy there. So I look up at the camera to make sure that it fits, but then I start writing backwards. But anyways, those are personal problems that you don't really need to hear about. So, well, how do I do this? Well, you have to go back and take a look at your constraints. Well, you're constrained by this parabola here, which has this equation. So, wouldn't I just be able to plug in 1 minus x squared here for y? And that way, that would have a function of just one variable. Well, that's exactly right. So if I do that, then the area would equal 2x times y, which is 1 minus x squared. Okay. If I do a little simplifying here, I would get 2x minus 2x cubed. And now that I have it in terms of one variable, well, now I can get the derivative of it. The derivative of the area with respect to x is 2 minus 6x squared. Okay? And then we do the usual. We set it equal to 0, find the critical points, and find in this case, the absolute maximum. Okay? So if I solve this, I'm going to get that x squared is equal to, if I bring the 2 over, divide by 6, I'm going to get 1/3. And then I get the square root of it, and well, you get two values when you get the square root of it. But since we're talking about a length here, well, x would have to be the square root, the positive square root. Okay, so I get that x is equal to 1 over square root of 3. Now, as far as my interval is concerned, well, the endpoints in this case, you don't have any endpoints basically, because you can make x as small as you want, but you can't make x 0 because then you wouldn't have a rectangle. Also, the same thing with y. I mean, you can make y, you can scrunch this rectangle down here a lot, but then if you go to y equals 0, well, you wouldn't have a rectangle again. So that means that we only need to check this guy, make sure that it's a maximum. So let's do our first derivative test over here. So we have 1 over square root of 3, and so then how about so we have our derivative here, and so let's test. How about we test, well, 1 over root 3. How about 1 over the square root of 4. And so this is bigger than this guy, right? Because, well, square root of 4, that's bigger than root 3. So so that sounds good. How about over on this side? How about we test 1? Okay. So the derivative, well, 1 over root 4, that's really 2, right? So this is equal to 2 minus 6 times x squared, so 1/2 squared, this is 1/4, and so this guy is going to be 2 minus 6 over 4. That's the same as saying 2 minus 3/2, which is positive, and so that means that my function is increasing, as we would expect. And then if I plug in 1, this is 2 minus 6 times 1 squared. This is going to be negative. Tells me that my function is decreasing, which means this is a local maximum. So that pretty much answers the question, just that almost. This is asking me for the dimensions, and so the base is 2 times x, so the base is 2 over square root of 3, and then the height, is equal to 1 minus x squared. Well, x is 1 over root 3, so this is 1 minus x squared is 1/3, so the height would be 2/3. And so those are the dimensions. The base is 2 over root 3 and the height is 2/3. And that's it. Happy face.